Hello, everybody, and welcome to another episode of Plastics Man. All right, in this episode, we're going to be discussing the question, what is plastic? What are plastics? Okay, so let's start by looking at some of the definitions. So with Webster's Dictionary, if we take a look at Webster's Dictionary, we'll go old school. What are plastics? All right, by Webster's Dictionary's definition, okay? All right, here we are. Plastic comes from the Greek word plastikos, which just means to mold. All right, so the first definition, capable of being formed or molded, capable of adapting to various conditions, pliable, sculptural, made or consisting of a plastic. Now there's a circular definition. All right, so if we go into the injection molding industry and we look at the book, What is a Mold? Let's see what they offer. Okay, the word plastic comes from the Greek word plastikos, which means able to be molded. So again, we hear that. So real quickly, while plastics have been with us most of our adult life in a variety of forms, it is important to understand how this material and the processes required to create plastic products have evolved. Okay, so really they're just saying it comes from the plastic word plastikos, and they give you some of the back history of what plastic is. Okay. Now let's get into the Plastic Engineering Handbook from the Society of Plastics Engineers. All right, this definition of plastic, let me see, where is it? Okay, here we are. Plastic. I think this is the most comprehensive definition, okay? So it's one of many high polymeric substances, including both natural and synthetic products, excluding rubbers. At some stage in its manufacture, every plastic is capable of flowing under heat and pressure if necessary, and into the desired final shape. So, made of plastic, capable of flowing under pressure or tensile stress. All right, so that's probably a good definition, but what we have to understand with plastic is we've got our academic definitions, but how does the public see plastic? So when we think of plastic, we think of detergent bottles. We think of makeup containers. We think of, well, this is kind of older now, but CDs in the case that holds the CDs. We think of all the products that we're surrounded by, but one thing that I understand from the public is that these are synthetic and we rely heavily on oil in order to create plastics. But I have to say this, the oil industry has a greater purpose. So it supplies energy to the world as we, take oil out of the ground and use that oil. There are many products that come from 1 barrel of oil. So if we think about the fractional distillation of crude oil, basically what we do is we heat the crude oil up and then we break that oil down into different materials, okay? So petroleum gases, gasoline, we have naphtha. Now naphtha is where the polyethylene and polypropylene molecules come from for plastics. And then you have diesel fuel, fuel oil, lubricating oil, and bitumen, which is used for paving the roads, pavement. So yes, plastics are synthetically derived. So when we say, what are plastics? I'll probably repeat that several times to stay on point and on topic. Plastics, they come from 2 places. Synthetically derived, that's what the public understands, which is very much, very accurate. And so that's from the oil, but they're also naturally derived. So let's take a look here. I have this all written down to help me out. Natural occurring plastics. They're divided into three classes based on their chemical structure. You have polysaccharides, proteins, and polyesters. So if we think about uh, plant derived, that would be cellulose. So the plant cell, like wood fibers and plant fibers, their cell coatings are made of cellulose, and those are plastic. You have animal derived, where you have chitosan, and that would be from shellfish. So you can basically take the shellfish and kind of dissolve the shell and make plastics from it. It could be pronounced chitosan. You also have silk, spider webs, wool. Now these are all proteins, and these are all polymers. Your skin is a polymer, believe it or not. So when we think about, like, how can that be? How can that be polymer? How can that be plastic? Well, plastic, all right. To be a plastic, it has to have a base unit, a monomer unit. So what you have is you have like a carbon and a carbon that are attached, and then these carbon have a hydrogen attached top and bottom, and that's the base unit. The thing about polymers is polymer means many mers, or many units. So you take that base unit and then you have another base unit and you attach them, and you do that again and again and again, and you create a molecular chain. That would be called, the more you have is the molecular weight of that chain, and the longer it is, the, the more it becomes a plastic, or the better the plastic is, let's just say. It's based on that chemical structure. So now we understand that there are synthetic and natural plastics. We understand how they come from oil, where they come from in oil, and then we understand that they come from plants and proteins from animals. So plastics, they're all around us. They've always been all around us. It's just understanding and educating the public on exactly what they are. And I like discussing how we're just surrounded by plastics. So if we have polyester, the shirt I'm wearing, if we look at paraffins, now paraffin is a byproduct from the oil distillation process, and that's candle wax. We have, let's look at vacuum cleaner housings. We have flossers here, battery container, those are lids for battery container, plastic bottles, containers, the medical industry containers, garbage can lid. We have transmission components here, tampon applicators, the Pez candy dispenser. I love these. I got a couple of them, a little Spider-Man here too. Catheters. And the reason I go over all of this, detergent bottles again, and I mean, everything we use, even for me to drink, my coffee here, plastics is everywhere. The container might be made of metal, but the coating on it's plastic. The cap, definitely plastic. That's probably acrylic. So yeah, another thing, the cell phone, the amount of plastics, epoxies in circuit boards. Epoxy is a plastic. So we're surrounded by it, and what are these things? I mean, it's again going right back to the beginning. They're made from either the oil distillation process, so from crude oil, or naturally occurring. So they're around anyway. So let's back up a minute and let's talk about oil. Well, let's get rid of oil. Well, if we get rid of oil, we're not going to be able to have the energy to heat and fuel our economies, but that's a different topic. But plastics are a byproduct. So the oil that already comes out of the ground, we're just taking what would be left over and thrown out, and we're taking that waste product and making something very useful out of it, plastic. So as a plastics engineer, I can't help but say thank you, because it's provided the roof over my head. And plastics makes a lot of things possible. You've probably heard that phrase, plastics makes it possible, and it certainly does. I mean, the coating on this desk is probably polyurethane of plastic. It's so useful. It's everywhere, and I thought it would be important for everybody to understand the usefulness and what plastics are. So when you see and want to understand a little bit more about plastics, you could take an everyday product and the recycling symbol on the bottom. This has the recycling symbol of a triangle with a 2 in it for HDPE, high density polyethylene. So this is polyethylene. Now, if we take the structure of polyethylene, which makes this detergent container, and we take the molecule and make it very, 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 very short, that little short molecular chain is candle wax. Now, before I said candle wax is also paraffin, that's two things that make up candle wax, paraffin and polyethylene. So, polyethylene in its very short chain is candle wax. It flows more readily, but the longer the chain, the molecular chain, the less it wants to flow, and the more solid and harder it becomes, the better the properties, again, like I said before. So we understand now that plastics, they're very prevalent, they're very useful, and I think we have a better idea of what they are. Okay, they're both natural and synthetic, and when you take the polypropylene and polyethylene that comes out of oil, so those are the two monomers, you can chemically extend those chains by adding the monomer, and you can chemically add additional chemical compounds. And when you do that, you create a new kind of polymer with different properties, which is why you'll get things like the CD is polycarbonate. You have acrylic. There's just so many different kinds of plastics, but they're all made from the base monomers. Now, why is that important to understand a base monomer? Because we know that they also can, that base monomer, I mean, coming from oil is one thing, but have you ever seen the landfills where there's pipes sticking out of landfills, old landfills that are covered with dirt, and then there's grass growing on them, but there's pipes sticking out anywhere? Well, if you haven't noticed, next time you drive by one, notice those plastic pipes, and what that is the exhausting of methane gas into the atmosphere. I think nowadays the newer landfills actually capture that methane gas, but methane is the base of the polypropylene monomer. So you can actually take a product that just gets wasted and capture it and make plastic. So if you think about your containers that you package your food in a kitchen, like the Rubbermaid or Tupperware containers, and the base of the container is clear, that's polypropylene. The lids, while a lot of them can be polypropylene, most of them are polyethylene. But again, they can be a derivative of either the methane gas from a landfill or from petroleum oil. So I think it's wonderful to understand that there's a kind of a relationship, a symbiotic relationship, where we have to get rid of our waste, put it in a landfill. Landfill creates methane gas. We would capture the methane gas and are able to make a useful product, plastics, out of it. I think that's just wonderful. So that circularity might not be understood by the public. So if understanding all of this, anybody has any questions, please put them in the comments and let me know so I can address some of the new questions a lot of you may have. And please subscribe and pass on and share this channel. In order to conclude, I want to go over some of the future topics that I'm going to discuss. Like, what are some of the things that are made out of plastic? And to kind of give you a little bit of insight, you have this, let's just say this is the lens of your sunglasses that you buy. And you can buy polarized sunglasses. And what's polarization mean? Well, if you have a pair of sunglasses, this is just gives you an idea what polarization is. I'll get into it deeper in another show, another episode. But if we look at the pair of sunglasses that are polarized, and this is another pair that's polarized, so is that a big deal? Well, polarization is fantastic for its application because I'll tell you what's going on that future episode. But if you take these, which are letting light through in one direction, and you turn them 90 degrees to each other, now light can't get through at all because they are 90 degrees to each other and light waves are prohibited from going through. So plastics is pretty slick. There's so many applications that are wild, something like that. So we'll talk about what's made of plastic. Where do plastics come from? We kind of touched on that today. Are plastics organic? What's organic mean? Now that's a common word. Everybody uses the, organic this, organic that, but in organic chemistry, so as a plastics engineer, I pretty much have a minor in organic chemistry. Organic just means carbon based. If I'm to really break it down to something simple, carbon based. And all plastics, just like us humans, carbon based, organic. That's the true definition of organic. All right. Why are plastics so prevalent? I kind of touched on that too. They're prevalent. It's fascinating to think about how you can come up with a product and almost make anything you want out of it, just about. So we'll discuss why they're so prevalent. We're going to discuss microplastics, both micro and nano. The big topic of the day is finding micro and nanoplastics in our bodies due to their breaking down, which is interesting because plastics are breaking down into micro and nanoplastics. A lot of people say plastics will be here forever. So we make this plastic product, this water bottle, you throw it in a landfill and it's gone forever, and it lasts forever in the landfill. When it doesn't, it breaks down. And we're going to discuss how they break down, and we're going to discuss if those, based on studies, like particularly from the National Institute of Health, NIH, what has been learned from these nano and microplastics that are in our bodies. So that's going to be another wonderful subject to discuss. So are plastics the problem then? Plastics, if we ingest plastic or put our foods in products in or touch plastics, are the plastics harmful? And I'll kind of reveal a little bit by saying this. Are the plastics harmful or the additives in plastics? Because there are many additives. In order to pop this out of a mold, you have mold release agents. In order to color it, like this white plastic for the cap, you have to put a colorant. In order to have properties to protect it from sunlight, you have UV stabilizers, things like carbon black. So we'll discuss a lot of those additives and if the additives themselves are what could have the potential to harm us. Now, when we talk about polycarbonate and PVC, there's a lot of discussion that has been released through the media about BPA and bisphenol A. And now that can mimic estrogen and hurt us. That's an additive, so we can have that discussion too in the future. We can talk about in a future episode, we'll talk about the reality of recycling plastics. And that's something I'm taking very seriously because I want to try to find, and I'm working on a solution to finding a best method starting right from the beginning of recycling plastics. I mean, when I talk about from the beginning, from the manufacturing process, we can't just count on the public to just take take labels off of plastic and then identify the plastic, put it in its appropriate container, and then hope that it goes to a recycling facility and finds a second life or even a third life, and then ultimately winds up in a landfill. So we'll discuss that and many more topics. So if there are topics you'd like to have me discuss and touch on, I'll reach out to my network in the plastics community if I don't immediately have the answer, and I'll certainly get the answer for everybody. So thank you again for joining this session, and I'll look forward to having future discussions with a little bit more education in plastics. Take care now.